Hi everyone, welcome to today's presentation which is about implicit differentiation. Today we will discuss what is implicit differentiation. So far we have been applying differentiation to the functions where one variable is being expressed in terms of other variable. For example, f of x is equals to x cubed minus 2x squared plus 7x minus 5. Here the function f of x is interchangeable with y, so we can also write it like y is equals to x cubed minus 2x squared plus 7x minus 5. Here you can see that the variable y is expressed in terms of the variable x. So the functions on which we have been applying differentiation is of this kind. But there are plenty of other functions that aren't set up exactly like this. For example, x square plus y square is equals to 9. This is the equation of a circle with the center at origin and radius is equals to 3. And this function has two different variables x and y. Now a question arises that how would we take the derivative of this function? In order to do this question, we need to use a technique which is known as implicit differentiation. Here you can see that we have a function with two different variables, and to differentiate this kind of function we need a technique which is implicit differentiation. So let's learn this technique by taking the same example I have discussed here. X square plus y square is equals to 9, which is the equation of a circle with center at origin and have radius 0. We know that we can solve for y in terms of x. We can rearrange this equation and we can solve for y in terms of x. Now we can take the derivative as we already know. But this can be difficult and time consuming, and sometimes it is impossible to separate the variables like this. But implicit differentiation will allow us to take the derivative of the function without having to solve it for one variable in terms of another variable. We can differentiate it as it is with the help of implicit differentiation. Let's differentiate it with respect to x. Then solve for y prime or dy by dx, the derivative of y with respect to x, which is what we are looking for. First of all, we have to take the derivative of this, as we have given the equation x square plus y square is equals to 9. We have to take the derivative. We will differentiate it with respect to x on both sides. It will become d by dx of x square plus y square is equals to d by dx of 9. Remember, do not forget to apply these brackets. This shows that we are taking the derivative of this whole function with respect to x. And as we know that the derivative of sum of functions is equals to the sum of derivatives, and the derivative of constant is equals to 0. So it will become d by dx of x square, the derivative of x square with respect to x, plus the derivative of y square with respect to y, which is equals to 0, as the derivative of constant is 0. Now we have d by dx of x square plus d by dx of y square is equals to 0. Now let's evaluate these terms. We are treating y as a function of x, and we should therefore imagine f of x anywhere we see y. So we will write f of x in place of y. So it will become d by dx of x square plus d by dx of f of x whole square is equals to 0. So when we take the derivative of x square with respect to x, it will become 2x raised to power 1, which is 2x. But for y square, it's difficult because we are not taking the derivative of y with respect to y, but we are taking the derivative of y square with respect to x. For that reason, we have to use the chain rule, and remember, as y is a function of x, so we use the chain rule. And remember, the derivative of composite function is the derivative of outer function times the derivative of inner function. The derivative of f of g of x is equals to f prime g of x dot g prime of x. And we imagine f of x raised to second power here, d by dx of x square plus d by dx of y square is equals to 0. Here we will use chain rule. So the derivative of x square is equals to 2x, and the derivative of y square with respect to x is d by dy of y square times the derivative of y with respect to x, and the whole equation is equals to 0. And we know that the derivative of y square with respect to y is easy, it's 2y. It will become 2x plus 2y dy by dx, which is equals to 0. Now we are left with dy by dx, which is the question. We want to find the derivative of y with respect to x. So we can also write dy by dx as y prime. It will become 2x plus 2y y prime is equals to 0. Now we will subtract 2x from both sides. It will become 2y y prime is equals to minus 2x, and then we will divide 2y on both sides. It will become y prime is equals to minus 2x divided by 2x. We can further simplify it, and it will become y prime is equals to minus x over y. And this is the derivative of the original function on with respect to x. This is how we use the implicit differentiation to differentiate the function which have more than one type of variables.